Welcome to classes on organic chemistry. Today's class is class number 5 and it is on higher secondary first year, and I have taken aromatic hydrocarbon, and this class is structured aiming at the all type of entrance exam, provided it is also helpful for the beginners higher secondary first year. So you minutely follow the class and you will find a lot of new things. Today I will explain whichever is not given in book, but you must know all these things if you want to know aromatic hydrocarbon. It is backbone of all hydrocarbon. In second year you will get hydrocarbon chemistry, uh, arene compounds. So aromatic hydrocarbon means, first I am giving a short definition. It consists of conjugated planar cyclic alkane accompanied with delocalization of pi electrons over alternate single and double bond. You minutely follow, a lot of things are there. One is conjugated, another is planar, another is cyclic, and next one is delocalization of electron. All the terms are very important and you must know all these terms, otherwise you can't understand. Planar structures, simple. It will take 1 or 2 hours more to explain what is planar structures. Simple, I will tell today. Planar structure means the carbon, if carbon is sp2 hybridized, means they are in the same plane. All the carbons are in the same plane. If carbons are sp2 hybridized, then they are on the same plane. If they are sp3 hybridized, 3 carbons are on small same plane and 1 carbon is above the plane. It is tetrahedral shape. Then planarity disappears. So simple, for your level you understand. Planar means sp2 hybridized carbon and they are on the same plane. What is cyclic? Cyclic means the structure is cyclic. First and last carbon is attached. It is not open chain. What is alkene? Means there is somewhere double bond or there are somewhere double bonds. And what does conjugated mean? Conjugated means if single bond is here in one carbon, in the next carbon there is double bond after gap of 1. This is alternate. Gap single, gap double, single, gap double. It is called conjugated. What is delocalization of pi electron? It is again very lengthy one. Delocalization means change of locality. That is, from one double bond in benzene, I will explain it in elaborate. One double bond pi electron due to overlapping of, you may not understand if you do not have knowledge of GOC, due to overlapping of p orbital, the electron single bond to double bond overlaps, and that in this way single bond becomes double bond becomes single bonds, again double bond becomes single bond. There is always alteration. So change of pi electron from one bond to other, that is alternate single bond over alternate single bond, means along alternate single bond and double bond always there is exchange. If these possibilities are there, these compounds are called aromatic. These compounds are called aromatic. There was a false notion about in the mind of maximum of the student. Aromatic means benzene. Yes, benzene is an example of aromatic. In due course of time, I will tell that besides benzene, you will get aromatic compounds. Benzene is not the example, one example of aromatic compounds. We always very often understand aromatic compound is nothing but benzene, but actually it is not true. A lots of compounds you will find they are also aromatic, but they do not contain any aromatic ring. We will get step by step explain all this. Now, these aromatic compounds, if they follow this, these are called aromatic compounds. Cyclic alkane, that's why I have not mentioned benzene. I have not mentioned benzene-like compounds. I have told here cyclic alkane. Am I right? So, these compounds are also called arene. Today, I will give you a new concept, which very often maximum of you do not have the knowledge of. For alkane, you know the formula of H twice N plus 2. For alkene, you know the formula H twice N. For alkyne, you know the formula H twice N minus 2. All the series, homolog series, has different formula. With the help of this formula, we can um, uh, write the structure of alkane, alkene, alkyne, ethane, methane, propane, butane, ethene, propene, like this. Am I right? So, do you know what is the formula of arene? The general formula of arene is arene is CnH twice N minus 6p. Where, very important, where C is equal to above 6. I am here showing you one is 6, other is 10, 6, 10, 14. You minutely follow these things, very important, 18, etc. Not less than 6, and that should be like this. I will tell why. And that is, sorry, not C, that is the value of N. That is the value of N. And what is P? P is the value of ring. How much ring? How many rings are there? P is the number of ring number. Am I right? Now I am effacing out and taking the example in a very simple way to make you understand how this, with this help of formula, we can write a lot of aromatic compound. Just you say, see the formula is CnH twice N minus twice P. C is the number of carbon, it starts from 6, 10, I have written earlier 6, 10, 14, 18, etc. And P is the number of ring. If N is equal to 6, put the value of P is equal to 1. If N is equal to 10, put the value of P is equal to 2. If N is equal to 14, put the value of P is equal to 3. Let's see what schema we can draw out from this figure, from this formula. You see 6, am I right? Hydrogen is H, 2 into 6 is equal to 12, minus 2 into P is equal to what? 1. Sorry, I am mistaken. The formula was earlier, I have written this way, it was wrong. CnH twice N minus 6p. Am I right? So here you write 6 into 1. So what you get here is A6. A bit later you will get the details of this one, and its name is benzene for the beginners. You may not know the structure of benzene. The structure of benzene is this, and you may write this. I will explain why we are writing two formula, two structures, or we may not give anything. We may give a big 0 inside the ring. You can write this one. The structure is for the beginners. Just I am showing you. C, 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 6C. Am I right? Give all single bond on each carbon. Am I right? And anywhere you give double bond. Anywhere. Say we are putting double bond here, alternate. Sorry, alternate. Double bond, single bond, double bond, single bond, double bond. Anywhere you start. Now you see how many valency of C is now utilized 1 2 3, one valency left, so fill up this valency with the help of hydrogen. This is nothing but the structure of benzene, C6H6. A bit later I will explain details on benzene. Am I right? This is benzene. So with the help of this we have got benzene. Am I right? Now you minutely follow the second one. If you put 6, how much? 10. Am I right? So hydrogen is equal to twice 10 minus 6. The number of P is equal to 2. This is 6 10 hydrogen. 20 minus 2, 12 is equal to 8. We have shown the ring is 2. Am I right? So ring is 2. You see. Again, you see the technique how to give the double bond, single bond. You start from here, one either above clockwise or anti-clockwise. Anyway, you move. I am moving clockwise. Gap, double bond. You don't give here. Pass on this one. Don't give here. Double bond. Don't give here. Double bond. Don't give here. Double bond. Am I right? This is naphthalene. This is NaPH THALEN. Naphthalene. Am I right? So how much? It has 10 carbon. 1 2 3 4 5 6 7 8 9 10. 10 carbon, and you open the structure and write as earlier I have shown you hydrogen. You will find 10 hydrogen and 8, sorry, 10 carbon and 8, 10. And this is naphthalene. Am I right? Now you put carbon 14. Am I right? Carbon 14, hydrogen 2 into 14 minus 6 into 3. Am I right? So you are getting C4H28 minus 18. Am I right? So you are getting C14H28 minus is equal to 10. So now carbon ring is how much? Ring is 3 ring. Am I right? So you give 1 ring, 2 ring, 3 rings. Now how I give double bond? You see, you start from here, 1, don't give here, 2, pass on next ring, not here, not here, not here, not here, not here. So you see, otherwise if you don't follow my technique, you can't give the double bond. You will very often give here double bond, other then your structure will be wrong. You count, you will get carbon 4. This is anthracene. This is anthracene. Am I right? So these all are arenes. Am I right? With the help of this formula we have written. Now the interesting fact is that if you are talking about arenes, now what are different type of arenes? Only compound containing benzene rings. Arenes, am I right? Aromatic arenes. We are dealing with benzene rings. So arenes, actually arenes, first of all you will get single ring structured. Second one, double ring. Better double ring, you will be confused whether ring is fused or ring is separate. Biphenyl structure. One is condensed structures. Single ring means benzene itself. Am I right? Benzene, or a lots of derivatives of benzenes are benzene, toluene. I am not giving ring. Phenol. Am I right? Benzaldehyde. A lots. All are single bond structures. Benzene. This is first type of arene. Now second structure, biphenyl. Now what is biphenyl? Two ring, benzene two ring, biphenyl. This is biphenyl. one, or biphenyl maybe like this. Um, Diphenyl methane. In methane, two phenyls are there. When benzene in group, it is called phenyl. Benzene in group, it is called phenyl. Diphenyl methane, or you can write stilbene. Am I right? So these are the some structures of biphenyl. Biphenyl, dimethyl this, and stilbene. Now what is condensed? A lot of condensed are there. A lot of. I have given you a bit earlier. You see, I am not drawing double bond. Just I am giving in this way. These are fused. That is, two common carbon is carbon to carbon, 3 carbon, 2 carbon, 2 carbons are common to both. In earlier cases, the rings are different. They are now common. Or I will tell the name. You just can note it down. Now we have talked something about arene. Am I right? Now let us come to the main point, which is the striking point in and each every time in entrance exam. This year 2023 question was from this part, which I am going to explain. In your state level or NCERT level or any type of entrance exams, the such questions are always asked from the topic which I am now explaining. That is aromaticity. Very, very important. The property by virtue of which cycloalkene the stability of cycloalkenes enhance due to delocalization of electrons in very, very important things. Many of you may not know what is aromaticity. Whenever we talk about aromaticity, we always give a lecture that it has a aroma, it has a smell, so smell this and that. These are some physical characteristics how we can understand it is aromatic. But basic fact is that property by virtue of which the stability of cycloalkanes enhance cycloalkanes enhance means it increased extra stability, and that property is called aromacity. Now I am giving you simple example. It is cyclo compound and it is alkane. Diene. Am I right? You can write in this way. You think about this, talk about this, and think about this. And if you see, this is unusually unstable, and this is unusually stable. Both are cycloalkenes, but one is stable, other is unstable. The reason for which it gains its enhances stability is called aromacity, and it is aromatic, but it is not aromatic. So we will now explain what is the reason a cyclic compound, one cyclic compound become unstable and other one become tremendously stable. This is a resonance energy. I will explain in details later on. Resonance energy in this one is very less, very low in comparison to this one. Hence, its energy is high. Its energy is less due to resonance. I will explain. Hence, it is extraordinarily stable, ordinarily stable. So the property by virtue of which the stability of cycloalkanes enhance due to delocalization of electron in pi electron. Why? Because electrons always changes. Double bond here, other time double bond here. Double bond here, other time double bond here. It goes on changing. It is delocalized, and due to which the energy become less. And this energy is called resonance energy. Due to this resonance energy, it is highly stable, and due to its stability, it very often during its chemical reaction, I will tell, very often doesn't undergo addition reaction. Under drastic condition it may go, but where there is double bond there is addition, where there is triple bond there is addition reaction. But this compound, due to its extra stability, it will not show easily addition reaction. It will not adapt something. Hydrogen you can't adapt easily, but substitution is possible. That property is also called aromacity, but it is instantly adapt to give the product because energy is high. It will breaks. Am I right? So this is aromacity. So when we talk about aromaticity, we will not forget one person's name, who is Haeckel. So again, before coming to Haeckel's, one thing I am here telling you, what are the criteria, Mach characteristics. Characteristics for a compound to be aromatic. What are the characteristics? What are the criteria? First of all, the compound must be flat. Very important, very important. Flat or planar. At the very beginning, I told you planar, in the same plane. Number two, it must be cyclic. Number three, it must follow Haeckel's 4n plus twice pi electron rule, where n is equal to 0, 1, 2, dot dot dot. Very important. Important to the infinity. Number 4, stability. Extra stable. If these criteria are fulfilled, the compound is aromatic. Otherwise, the compound is not aromatic. So these are the important criteria upon which, understanding which, you can very easily say this compound is aromatic and this compound is not. So tell something about Haeckel's. This time question comes, which one of the following is not aromatic? Now I will explain Haeckel's rule. Haeckel's. What does Haeckel's tell? Haeckel tells 4n plus twice pi electron rule. That is n is equal to 0. Am I right? N is equal to 0. One thing just beforehand I am telling you, n is equal to 0. There is 2 pi electron. 2 pi is equal to 1 pair of electron. 1 pair electron. N is equal to 1. 6 pi electron. Sorry. 3 pair of electrons. Equal to 2. 10 pi electron is equal to 5 pair of electron. N is equal to 3. 14 pi electron equal to 7 pair of electron. So 7 pair of electron. Earlier I have told you to, whenever I gave the formula of arene, 6NH twice N minus 6P, then I have told you the number of N should be 4, 14, 18, etc. So you see there is some similarity. There is, except 2, 6, 10, 14. These things are coming. So these are very good numbers. These are very good numbers. In any structure, if you count the electron without using any formula, you count the electron. If the electrons are 6, if the electrons are 10, if the number of electron is equal to 14, then it is blindly you can say it is aromatic. And if the electron number is 2, but there is some exception, I will explain. There some critical point is there. If there is 6 electron, so let me take one example. Let me take one example, you can understand very easily. Say this, there is pi, sigma, 6 sigma, 3 pi, all are sigma pi, sigma, 6 sigma, and other is pi, 6 sigma and 3 pi, and one hydrogen is there. Am I right? Hydrogen is there. We are not talking about hydrogen, just I am showing you. These are also sigma. So all these are sigma and 3 are pi electrons. So one bond is equal to 2 pi electron. 2 pi electron. One bond is equal to 2 pi. In double bond, one double bond is equal to, there is 1 sigma, 1 pi, that is 1 pi has 2 pi electron. So one bond in double bond will be equivalent to 2 pi electron. If two bond, so you see how many double bonds? 1, 2, 3. So 1 pi has 2, 2, 2. How much electron? 6 pi electron. So if it is 6 pi electron, it is blindly aromatic. Now you see if you draw naphthalene, am I right? So say this gap, this gap, this gap, this, am I right? How many electrons here, sir? Double bond 1, 2, 3, 4, 5. One double bond has 2 pi electron, 5 to the 10. 10 electron. 10 electron is there. It is what? It is aromatic. It is aromatic. So one another inference you can draw from this thing, if the electron pair, not number of electron, is pair. If pair is odd, if electron pairs are odd, then no doubt the structure is, the compound is aromatic. Say if there is 2 pair of electron, means 2 pi electron means 1 pair odd, it is aromatic. If there are 6 pi electron means 3 pair, it is aromatic. If 10 number of electrons means it is 5 pairs, it is odd. All odd pairs of electron give rise to aromatic compound. Now this is my theoretical concept. If you keep it in your mind, well and good. Now if you cannot, now what are the things? I am showing you how you can find out. Say I am taking the structure of benzene. Am I right? So say this is benzene. Say this is benzene. So in benzene, what is its formula? Formula is 4n plus twice pi electron. Am I right? So what is 4n? 4. N. We don't know n. Am I right? We don't know n. What is n? The value of n is equal to, earlier I have written is 0, 1, 2, 3, 4, 5, 6, etc. Am I right? So I don't know what is n. 4n plus 2 is equal to, but we can count the number of electron. It is 1, 2, 3 pair, 3 to the 6. So we will not get n is equal to 1. When n is equal to 1, it is 6 electron. But in Haeckel's rule, we have seen the value of n is equal to 0, 1, 2, 3. So by counting the value of total number of electron in and equate it with the Haeckel's formula, if you find the value of n either 0, 1, 2, 3 whole numbers, blindly it is aromatic. If the value of n is 0, 1, 2, 3 whole number, by calculating the number of total electron and comparing with the Haeckel rule, if you find the value of n, and if it is 0, 1, 2, 3, 4, 5, 6 whole number, then it is aromatic. It is another way to calculate aromacity of a compound. Am I right? So now after this much, you are quite happy. I think you can understand which one is aromatic and which one is not aromatic. Now I am telling one thing. Say this is the compound. This is the cyclopropene, and here I am giving you plus cyclopropyl cation. Cyclopropyl cation. Now here is 2 electron. Am I right? We know one pair has 2 electron, and earlier I have shown you if the number of electron is equal to 2. If it is 2, if it is 6, if it is 10, if it is 14, they are aromatic. So according to our concept, it is aromatic. Number of electron is equal to 2. Now let us put in Haskell formula. 4n plus 2 is equal to 2. Therefore n is equal to 0. Have I not got where in Haskell formula n is equal to 0, 1, 2, 3, 4? From this point of view, it is again aromatic. If it is 2, okay, it is aromatic. And if you can't understand how it is 2 or how it is why it is aromatic, you create with total number with Haskell's formula. You will get n is equal to 0, and you check what is the value of n given in Haskell's formula. It is 0, 1, 2, 3, 4. Am I right? So it is aromatic. Now question arises, if you give the formula like this, 2 hydrogen here means hydrogen 2 are there. I have shown you already there is 2. Cyclopropene. Here also there is 2 electron. Is it aromatic? No, it is not. Now why? When plus is there, it is aromatic. When plus is not there, it is not aromatic. Means the criteria was delocalization of electron should occur. It is planar, no doubt, in one plane. 3 carbons are in single plane. It is planar. It allows or satisfies Haskell rule. Second point is also there. But third point, delocalization of electron must there. Means electron should run, move all through, around all carbon. It is not doing so because you cannot withdraw this electron here suddenly. But here delocalizations occur. I will again explain this one. Here delocalization is occur, here doesn't. Now next part, as per your text, there is a point that aromatic compound, not arene, 3 types: single bonded carbon, single structured carbon, biphenyl structured, condensed structure. Now we are talking about aromatic compound. Aromatic compound, what are the types? This is benzenoid and non-benzenoid. There is a critical concept I will show you now. Non-benzenoid. Both are aromatic, but one is benzenoid, other is non-benzenoid. What does benzenoid means? Benzenoid means in the structure one, at least one benzene is there. One benzene is there in the structure of compound which you are trying to prove whether it is aromatic or not. We can instantly tell whatever the big structure is this structure. If it contains any benzene and whatever other branches are there, then it is benzenoid structure. So what is the example of benzenoid structure? Benzene itself is benzenoid. Am I right? So in benzene, if you substitute one hydrogen by OH, phenol is also. If you do in this way, toluene is also. If you give here NH2, aniline is also. And lots of this. Otherwise, you biphenyl. Am I right? Or condense 2 benzene ring, 3 benzene ring form. All are benzene structures. So if only at least one benzene ring in the structure, these are called benzenoid. Very simple, you can understand. There is no confusion. But confusion arises. Where it arises? It arises non-benzenoid. Non-benzenoid. It is cyclic arene. The compound is cyclic alkene. Must be cyclic. The condition was, first of all, I have given you, must be cyclic, must be flat, must be delocalization is there, must be stable, must follow Haskell's rule. Am I right? So non-benzenoid, if it is aromatic, so that should be alkene at least with no benzene structure. It is cyclic alkene, but no benzene structure are called non-benzoid. Am I right? So I will give you some example. You can very easily understand that yes, these are uh, benzene aromatic compounds. Same. Minutely follow. These are the very important things. So cyclic alkene with no benzene ring in the structures are called non-benzoate, but these are aromatic. So say uh, you have got this. I don't know have you got this, but you saw this one. This one, this one, this one, this one, this one. This is furan. These are very important. You keep it. Furan, thiopine, pyrrole, pyridine. So you see, all are aromatic. Now, how will you explain aromacity of this one? You apply Haskell's rule. How much electrons are there? 1, 2, and lone pair is also 1. 1 pair. How much pair of electron? 1, 2, 3 pair. So 3 pair, 3 to the 6. So according to my formula, 0, 6, 10, 14, 18, it is aromatic. Otherwise, you compare it with this. Are you not getting n is equal to 1? So Haskell's rule 4n plus twice pi electron rule, where n equal to 0, 1, 2, 3. So you have got whole number 1. Am I right? So it is aromatic. Another explanation is that it is planar. Another explanation that it is stabilized. Another point is that electrons are delocalized. Lone pairs comes here, this bond withdraws, again this bond comes here, this bond withdraws. Am I right? I will show you aromatic how aromatization occurs, delocalization occurs in benzene. I am coming step by step. I will show. So this follows delocalization. It is stable. So all the five or 4 points I have given earlier is complied by this formula. All this formula will comply Haskell's formula. So all are aromatic, and these are non-benzonoids, and another special name is it is non-benzoid, no doubt, no benzene ring, non-benzoid, but in non-benzoid we are getting another thing, it is called heterocyclic aromatic compound. How heterocyclic? Means when more than one number of carbons are in a cyclic manner, fashioned in a cyclic manner, and one or more carbon is replaced by oxygen, sulfur, nitrogen, etc. In the cyclic structure, one or more carbons are there, and in place of other carbon, if sulfur, oxygen, nitrogen, or other heteroatoms are included in the structure along with the carbon, then it is called heterocyclic. So no doubt not benzoid, but it is heterocyclic. So in exam sometimes you are asked this compound is heterocyclic, non-benzoid type, or this type, benzoid type. You are asked to tell the fact. Am I right? Sometimes you are given assertion and reason, and you are given a compound and this. Now again non-benzoid. I am giving you a structure. You count, there are 7. Am I right? 1, you see. Again you count, it is 7. Am I right? Again you count, it is 7. Again you see, so it is compound. A lots of question from in entrance question comes here from here. Topolone. I am telling the name cycloheptatrienyl cation. That one cyclopropynyl cation. Likewise, and if you are asked whether they are aromatic or not, you can very easily tell aromatic because there is 1, 2, 3 in 3 to the 6 electron. Obeys Haeckel rule. 1, 2, 3 6 electrons. 1, 2, 3 6 electron. 2 6 electron. 1, 2, 3 4 5 5 2 10 2 6 10 14. Again it is aromatic. 1 2 3 4 5 6 7 14. Again it is aromatic. It is called 14 annually. Am I right? So this is all are aromatic. Now I am telling you whether these compounds has contained any benzene ring. Certainly answer is not. So they are nothing but non-benzoate. So earlier we have drawn another non-benzoate, but that are heterocyclic. In the benzene rings there are carbon in place of another carbon. You have entered nitrogen, oxygen, sulfur, like these compounds. But have you got replacement of any heteroatom like oxygen, sulfur in this one? These are not heterocyclic, but they are also non-benzoate. So these all compounds are also non-benzoate and they are aromatic. Non-benzoate and aromatic. So in non-benzoate you have 2 points. One are heterocyclic, aromatic. In the cyclic system, in place of 1 or 2 carbon there is replacement of oxygen, nitrogen. But in cyclic structure there are no replacement, and if they follow this, they are aromatic. So we have got in benzene aromatic, benzoate and non-benzoate, and have explained in details whether these compounds are aromatic or not. So non-benzoate aromatic and benzoate aromatics, we have explained these two. Now another 2 things, these are very very important. One is anti, in entrance, anti aromatic. Don't get nervous, just keep it in your mind. Anti aromatic. These are cycloalkene having unusually instability and follow foreign structure where n is equal to 1 2 3 4 are called anti-aromatic. Now what is anti-aromatic? Let us explain this. Say this too. So if you put n is equal to 1, how many electrons are there? 4. So 2 pair, 4 electrons. It is anti-aromatic. It is planar. But what compound means 4, and if you put 2 means 8 electrons. Let us see a compound I am showing you. Eight electron. It is 4 in type, where n is equal to 2. So is it? It is anti-aromatic. In higher entrance exam it comes. No, though it is 4n, it should be anti-aromatic, but it is non-aromatic. Non-aromatic, because they are anti is unstable. Anti is unstable, but non-aromatic may be plain alkene, maybe cyclic, but they are stable. Now next question, since it follows 4n means n is equal to 2 is 1 2 3 4 8, it follows 4n. Why not it is anti? Why it is non-aromatic? Because its structures again distorted in this way. And lots of ways are there. Lots of ways. Also, due to this distortion, the planarity is disrupted. They doesn't no longer remain in the same plane. So plane changes. When plane changes, the resonance doesn't occur. Doesn't disrupt or disrupted. Hence, it is non-aromatic. The structure is tube-like structure. It is non-aromatic. So we have got anti-aromatic and non-aromatic. So in aromatic, in your chapter, we have got benzenoid, non-benzenoid, heterocyclic, and I have given you two more, anti-aromatic and non-aromatic. Anti-aromatic is 4n type, and non-aromatic, it is unstable, it is cycloalkene, planarity is lost, delocalization is resonance is disrupted, and tetraene, cyclooctatetraene structure should be n is equal to 2, should be anti-aromatic but non-aromatic because it is unstable, it is stable. So these are the type of compound we have got in this structure. So if we next class, I will explain, I will focus on benzene, its structures, its hybridization, its stability, and its reactivity. Mind that in second year, whole chapters containing array. It is backbone of the aromatic compound. So don't miss my next class. Hope you have enjoyed the class.